So the first one, here's another Ferris wheel question. Numbers are obviously different. There's a couple other things that are slightly different about this that we will take a look at. Calculator? Ruler? So this one has a diameter of 20 meters and completes one full revolution in 4 minutes. And the center of the wheel is 25 meters above the ground. Remember what I said yesterday is if you are not given a diagram like this, you could make your own if you find it helpful. Ultimately, you need to make the sketch of the curve and you need to write the equation, but this can be useful to just organize the ideas and visualize it. But make sure you know that when it says graph, this is not what it means. It doesn't mean draw the diagram or a picture of a Ferris wheel. Not at all what we're looking for, right? If we look at the lesson from yesterday, I scroll up, once it loads here, that's the graph that it means. Sine curve or cosine curve. And I gave you the hint yesterday that a lot of these, it's easier to do cosine. That's sort of your tip. So how are we going to start labeling this? I don't know where you start. Everybody's different. There's a few things you need to think of though. The center of the wheel is 25 meters above ground. We'll talk about why you need to think of that and why that's important when we get there. And the Ferris wheel has a diameter of 20. If it has a diameter of 20, what else do I know about it?
Radius of 10.
It's got a radius of 10. Why is that important? Okay, we'll come back to that. If I want to sketch, oh, and then we did this yesterday, one revolution in 4 minutes means it goes from 0 to 4 there, means after a quarter of the way, that's 1 minute, 2 minutes, 3 minutes, and then 4 minutes or 0 minutes. So you might think about those positions as well. In particular, where it starts and where it is halfway is going to be important for when we draw the sketch of this. What's different from today compared to yesterday is this doesn't have a grid or a scale or anything on it. If you're given the grid and it's got the scale, then you're graphing it just a little bit more accurately. You got to find the right points. If you're given an axis like this, or if you're given no axes, you would draw in your own, hopefully with a ruler. You don't have to tick mark a scale. So I hope nobody's already started doing that. Okay. We're just going to sketch it and label the important positions. So this says, assume the rider gets on at the lowest possible point. So I'm just going to stick a point here on the graph. But do we know what point that is? Hold on, so then it says 2 rotations. We're going to do cosine because it's easier. So 1 rotation would look like that. Back to the minimum again. And then another rotation would look like that. So this is 4 minutes to go a full rotation from the bottom to the top, back to the bottom. So halfway getting to the top, again, we already put this, it's those green marks, would take 2 minutes. So this would be 2 minutes. This is 6, and this is 8. And my scale's a little bit off there, but that's okay. It's just a sketch. It's the labeling that's important. So this is obviously time in minutes. So T for time. And this will be H for height, height. Again, in this case, it's in meters. But I have to label the height scale. So what is my lowest point? We're going to label the lowest, the highest, and the middle. Zach, what's the lowest point?
5.
Why did you say that?
Because the diameter is 20, and then from the center of the circle to the ground is 25, so the difference is 5.
The difference between 20 and 25 is 5. What's this distance?
10.
10. So if this is 25 and this is 10, how much? 15. So be careful, we want that radius, the difference between the rate, and this is obviously not a good diagram because it does look a lot more like 5, but that's going to be 15 meters. 15 meters up to the bottom of the Ferris wheel, 10 more meters to the middle, 10 more meters to the top. And so the very top is going to be, the middle is 25. I'm going to go up 10 more because that's the radius. And the very top will be a distance of 35. Good. It starts to get a little clumpy when we put all the measurements over here on the side. But some people might like to break it down that way. I don't know. But you do have to think about every single one of those details because we need to know that this is 15, this is 35, and this is 25. And put your pencil down, folks. Take a look here. What is this? 10, which is the radius, which is also the amplitude. This is my 0 line. So those are all details we absolutely need. You've got to break it down into those parts. All that work we did with graphing and with coming up with equations, what did we always talk about? What's the amplitude? What's the max? What's the min? What's the 0 line? And then the shift, the phase shift, and the change in period. So we do have to think about the period and to find the K value. But to me, this is the work, is taking the description of the heights, diameter, all that stuff, and turning it into the properties of a trig function, amplitude, max, min, 0 line. Okay? So, showing time in seconds. We're going to change that to minutes, but we're actually going to talk about both, but we'll get to that in a minute. Write an equation for your graph. So let's do that. So for an equation, what do I need? I need the A, the K, the C, and the D. C is easy. It's just going to be 0. If you want it, you could start with that. D is relatively easy. It's the 0 line. Like we've already got a bunch of this done. D is the 0 line. So that's 25 in this case. The amplitude is the radius, so that's 10, half the distance from the max to the min, or the distance from the 0 line up to the max, and the distance from the 0 line down to the min. And that means my A value, what do I need to think about for my A value?
If there's a reflection.
Yeah, and in this case there is. We start at the minimum. That's a reflection for cosine. So it's negative 10, because otherwise it's the same as the amplitude. And then what about K? Well, I got the period is 4 minutes. So my K value is 360 divided by 4, which works out to what? 90. Okay, so for B, height at time t is the A value. We're using cosine, you got to remember that. And then the K value times t plus d. And that's in minutes. This is going to be really important because the next question says, what is the rider's height after 40 seconds? But I can't put 40 in here because this is t in minutes. This is not something that I'm going to require you to do much of, but I think it's important in real life that we realize it's not always as easy. Sometimes this is the hardest part of these kinds of questions, is thinking about the units. So I thought we could try one together today, but normally if it asks you to do it in minutes, I'm going to ask you to do everything in minutes, or it would be like 60 seconds, which is easy to convert to minutes. I might give you a question like that. And if you did this in minutes and put 60 in there, that would be bad.
Would you just convert it to decimals?
Yeah, you could convert the seconds into a number of minutes. We're going to talk about how to do that momentarily. The other thing we could have done is we could have done all the work in seconds. How many seconds is in 4 minutes? How do you figure that out? 240, how'd you get that? So you do 60 times 4, and it's 240 seconds in 4 minutes. So that would be 240. This would be 120. This would be 360 and 480 if it was in seconds. And if you got an actual question like this, you would have to decide which way to do it. You can't mix. So right off the bat, it would make sense for you to say, I think it'll be easier in seconds. I'm going to do the whole thing in seconds. Or I think it's easier in minutes. I'll do the whole thing in minutes. So you don't have to write this down if you want to just watch, but you can also copy it down if you want. What would the equation be? My K value is the only thing that would change. It would be 360 divided by 240, which works out to 1.5. So this would be negative 10 cos 1.5 t plus 25 if I did it in seconds. Okay, last thing that we'll talk about before we start question C is if you're doing it in minutes. This is the harder thing to me, a little bit trickier. Converting minutes into seconds, most people have an intuitive idea of how to do that. How do you convert seconds into minutes? So 40 seconds is 40 over 60 minutes. So you divide by 60 to turn it into a number of minutes. And that ends up being a fraction or like a sort of a nasty decimal, not an easy one. You can't round that. Okay. So we're going to do this. We're going to do question C twice. We're going to do it in minutes. And I'd like you to use your calculator to try both of these. So this is 90 times 40 over 60 plus 25. You're going to punch that whole thing in. Or, if you're doing it in seconds, okay, so here's mine. So I'm going to do it in minutes first. Negative 10. Remember when I encourage you to try to type these in all at once. Negative 10 cos 90 times 40 divided by 60, close bracket, plus 25. So I got 20 exactly. Nice. Now I'll do the other one, which is over here. Negative 10 cos 1.5 times 40, close bracket, plus 25. 20. Exactly the same. And it better be. Therefore, the rider is 20 meters high at 40 seconds. Which way do you think is easier? Which way do you like better, minutes or seconds? It's good to think about it, but like I said, I wouldn't require you to do too much conversion. But if it would be simple if it gave you all this and then said in 60 seconds, you better be able to figure out that that's 1 minute. Okay? Or maybe even 90 seconds, 1.5. You can think, is that an easy conversion to make something like that? Any questions? Oh, so again, just to recap, one of the other differences here was that no scale, you're showing a sketch, but to be very clear, the sketch requires these 3 labels on this side. Try to draw it reasonably accurately, but it doesn't have to be perfect, that's for sure. Scale on the bottom, marked at least those intervals. Okay? That's what I would be looking for. And then your axes labeled as well, height and time, that sort of thing. All right, let's try one more. This is very similar to one we did yesterday. Off the coast of Cape Town in South Africa, the tide ranges from 8 meters to 2 meters. The other question gave us diameter. This one gives us the max and the min. So slightly different, the information that they give us. One complete cycle takes about 12 hours. That makes it nice and easy. Sketch a graph of water level starting at high tide for 24 hours. So because it gives us those exact values, this should be pretty easy. It goes from a max of 8 to a min of 2. So if I put 2 here, this is depth in meters, and I'll put 8 up here. I'm not measuring this out with a ruler. A bit of an estimation of where these numbers would go is good enough for me. This one starts at high tide. So it's got to end back on high tide to get 2 full cycles. To write the equation, we have to find the middle anyway. So we're going to find it and mark it on our sketch. 1 full cycle happens in 12 hours. So to get to the bottom is 6. Every 6 hours it's going from the, so that's 18, from the top to the bottom and back. And I feel like this visual helps even all the stuff that we've been doing, thinking about amplitude and max and min. When you see it on the graph, what is the change from 2 to 8? What's the difference between those? The total distance from 2 to 8.
You asking for the amplitude?
Not the amplitude, the total distance from 2 to 8. Say again? Not plus. 6. Okay? So this distance is 6. To go from 2 to 8, you'd go up 6. And so then half of that is going to be the amplitude. So I'm going to go down 3 and then down 3 more. Right? So it helps you kind of visualize. And that means this line is where? Because we need that line for the equation. At 5. 2 up 3 is 5. 8 down 3 is 5. So pretty much all we have left to do here is find our K value. Oh, I'm going to write the period down first. So the period is 12. So the K value is 360 divided by 12. This is the same as yesterday. It works out to 30. Go ahead and try to write that equation. Think about whether it's reflected or not before you start. 3 coast 30T plus 5. And then the last question, if high tide, remember we did a question just like this yesterday. So, and use your graph. Think about your graph. If high tide is at 4 a.m., what's the depth of water at 8 a.m.? How many hours is that? From 4 to 8 is 4 hours later. So I'm not putting 8 because that's 8 hours after high tide. 8 a.m., if this is 4 a.m., 4 hours later is 8 a.m., so that would be right around here. So I'm putting 4 in because it's 4 hours after high tide. $3.5. Therefore, the water level is 3.5 meters at 8 a.m.